All right, on my math lab, they're going to ask you something like this to use your calculator with. They're going to ask you evaluate 3 to the square root of 5. That's 3 to the square root of 5. So on your calculator, you're going to do this. So your base is 3, so you can say 3 raised, this is your raised function right here. So you see how it looks like an exponent? In parentheses, always put your exponent in parentheses to be on the safe side. Parentheses, and then I need to put the square root of 5. How do I get the square root of 5 in here? How do I get square root? So, you see the square root is right above the x squared. You see it right here? So second x squared gives you that square root. You can see it right here, square root. And I'm taking the square root of what number? 5. Now be careful. You have, on the left of 5, you have 2 open parentheses. You got to close them. So you can say close, close. And then press enter. And to the nearest, they may ask the nearest hundredth. To the nearest hundredth, what is it?
11.66.
11.66. Okay. All right, so in my math lab, they are going to ask you to approximate something like this. They're also going to ask you this. Approximate e to the 1.2. E to the 1.2, let's say. All right, now we haven't talked about e. You don't know what e is. We're going to look at that in a little while. But for right now, locate the number e. It's a number. It's not a variable. It's actually a number. Locate the number e on your calculator. It's right above. Yeah, see right here? Here's the ln. It's right between the ln and the log. But to get to it, you got to press what function? The second function. Okay? All right, so you're going to say second e to the x. See what it looks like? So when you do it, it automatically puts a parentheses there for you. And inside the parentheses, what number do I need? 1.2. Close it. Press equal. And e to the 1.2 is approximately equal to 3.32 to the nearest hundredth. Okay. What if I just asked you this? What is E? What if I asked you, what is E? What is E approximately equal to? How do you do that?
E to the first.
E to the first, good. So E is E to the first. The exponent is understood to be a 1. So you say second e to the x, right here. You get this. So you got to put an exponent there. What's that exponent understood to be? A 1. Close parentheses. Press equal. E, and let's round to the nearest thousandth this time. So E is approximately equal to what decimal to the nearest thousandth?
2.718.
2.718. Okay? Now, this number, does it terminate? No, does not terminate. Is there a repetition anywhere? Where? Now remember, but just be careful. Be careful the end. Be careful the end. It actually rounds off the last digit here because of the. Remember, your calculator always rounds off of the last digit. Where's the repetition?
182.
That's not an 8. Over here, it's rounding off to the 8. So that's probably a 7 something. Okay, remember your calculator always rounds off. So be careful. Yeah, go ahead and put that in on Google.
So they put a line over the 8 if it continues going?
No, your calculator does not do that.
So how do you know if it's continually going? If it's continually going, like a pattern is continually going on
It rounds to.
So hold on. So you would like you see that E is not a rational number. It's not like 2/3 or 4/5. Those are rational numbers. Either they terminate or they repeat. Any other number that doesn't look rational is irrational, like the square root of 5. Square root of 5 is irrational. If you put square root of 5 in your calculator, you get this. And her question is, how do you know if it terminates or it doesn't terminate? Because of your calculator. You got to know that the square root of 5 is an irrational number. All irrational numbers don't terminate. If a decimal terminates, then it's what kind of number? Rational. 0.2 terminates. What is 0.2 as a fraction? 2/10. Square root of 5 is not a rational number. The square root of 1/4. Square root of 1/4. Is that rational or irrational? Square root of 1/4. Is that rational or irrational? It's rational because what's the square root of 1/4? It's 1/2. 1/2 is what decimal? 0.5. It terminates. So to answer your question, you need to know whether it's rational or irrational. Because she's looking at this and she says, well, I don't know if it terminates or not. Well, you got to know that the square root of 5 is what kind of number? Irrational. So it's not going to terminate. And an irrational number, guys, an irrational number doesn't have any repetition at all. For example, 0.3333 repeating. You got to remember some things you learned in a previous course. This is not college algebra here. That's a previous course. 0.3333 repeating is what fraction? 1/3. 1/3 is rational or irrational? It's rational. A rational number, guys, is where you have an integer divided by an integer. So a rational number is a number that either the decimal terminates or the decimal does what? Repeat. Okay. So E, based on all this we just said, is E rational or irrational?
Irrational.
It's irrational. There is no repetition, although it looked like it, because remember your calculator, that last digit always rounds off on the last digit. You may not know that.
Google does too.
Google.
It rounds off.
So you only rounded off to a certain digit?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 place.
Okay. All right. So second, we say e to the x. So to the nearest thousandth, you're going to say it's approximately 2.718. Okay. All right. Now let's talk about what E is. Okay, you see this expression right here? 1 plus 1 over n raised to the n power, that's an n.
Zoom in a little bit.
I'm not going to make it any better. This expression right here, that's 1 plus 1 over n raised to n power. That's an expression that occurs quite often in many courses, in many applications. So from this point forward, as you take your science classes or your math classes, you're going to see this number E appear more often. So if n is 1, look carefully, if n is 1, then I want to know what is 1 plus 1 over n raised to n power. So if n is 1, what's 1 over 1?
1,
1 plus 1 is 2. 2 to the 1 is 2. Okay? If n is 2, I get 1 plus 1 over what? 2 raised to what power?
2,
Second. Now use your calculator on that. So on your calculator, say this. Say 1 in parentheses, 1 plus 1 divided by 2 raised to the second power. You get 2.25?
2
Okay? If n is, let's say, 6, if n is 6, I get 1 plus 1 over 6 raised to what power? 6. Use your calculator and tell me what that is approximately equal to. 2.52? Is that what you said?
Yep.
Okay. If n is, let's say, 20, 1 plus 1 over 20 raised to the 20th power. What is that?
2.65.
2.65? If n is 100, I get 1 plus 1 over 100 raised to the 100th. What is that?
2.70.
2.70? And this time, let's just go ahead and give me one more decimal point. Let's round to the thousands. 2.70 what? 5? If n is 1,000,
2.71 or 2.72 if you round up.
let's nearest thousand.
2.72.
Nearest thousand, that's a hundredths place.
Okay, 2.717.
Okay? If n is 10,000, what's 1 plus 1 over 10,000 raised to the 10,000th power?
2.718.
If n is 100,000, what's 1 plus 1 over 100,000 raised to the 100,000?
2.718.
Okay, give me another digit.
3.
All right. And what was the one over here? Let's do this one here and do the 10,000s. That's fine. So 1 plus 1 over 10,000 raised to 10,000. What was that?
2.7181.
Okay. Now what I want you to notice is this. As my n values are getting bigger and bigger and bigger, what are my y values getting closer to? Huh?
3.
E. Thank you. It's getting closer to E, the number E. So if you kept on going, guys, if you put 1 million, it's going to be close to 2.718. If you put 1 million, if you put 2 billion, 2.718 is close to. So as n gets bigger and bigger and bigger, and I'm talking large numbers for n, it's getting closer and closer to what number? E. You're going to learn that in calculus. It's going to be listed like this. You don't have to know this in here. But the limit as n goes to infinity. Oh, I'm sorry. I had zoomed in. Y'all didn't say anything. I wasn't looking. I'm looking at this. So the limit as n goes to infinity, meaning as n gets bigger and bigger and bigger, as n gets bigger and bigger and bigger, This expression up here gets close to what value? E. That's what it's close to. So that's where E comes from. So E is a number that when you evaluate this expression, and as N gets bigger and bigger, that's what E is.
I take it never gets there.
Hmm?
I take it never gets there.
Never gets where?
It never gets to E.
Well, E is E.
So I'm talking about the N, the 1 plus 1 over N. As you increase the number, it never actually gets to E.
It gets closer and closer to E, which we approximated as E, which we say is E. Okay, you could go to 500 billion, 100 billion. It's getting closer and closer to that number E. See that number you typed in? That is your E. The number you showed me on that has hundreds and hundreds and hundreds and hundreds of digits to infinity, that's E. They never did approximate what's that last digit because there is no last digit. Remember, it's irrational. It never stops. But that's what we're saying E is this expression as N gets bigger and bigger and bigger. Now, it does have some applications, and you're going to see some applications in here. But next semester, you're going to learn the word limit next semester. Limit. We just abbreviate LIM. So here's what I want you to see. That's that table. So notice as I started using larger and larger numbers for N, I was getting closer and closer to what value? E. Right here. You can't see it, but that's E. That's E. Okay? All right. Now let's graph E. So let's graph g of x equals e to the x. G of x equals e to the x. You graph it just like you did the previous ones you did. And this is probably the 5th day you've been dealing with this. We've got to finish this today. So let's graph g of x equal e to the x. Now you need your calculator for this one, because e is what kind of number? Irrational. E is an irrational number. What's the other irrational number that you use a lot often in high school? Pi. Pi. Now, are those two the only irrational numbers you ever dealt with? No. You had it in here. The square root of 24 is what kind of number? The square root of 24 is what kind of number? Rational or irrational? Irrational. The square root of 16, rational or irrational? Rational, because square root of 16 is 4. All right, so here we go. What's the horizontal asymptote?
Y equals 0.
Y equals 0. The horizontal asymptote is y equals 0. What is your y-intercept? To find the y-intercept, you let x be what? 0. So if x is 0, get e to the 0. What's e to the 0? 1. So your y-intercept is 0, 1. I'm going to ask you the same questions I asked you earlier. Is this graph above or below the horizontal asymptote? It's above because you don't see a what? A reflection. You don't see that negative out in front. Is it an increasing or decreasing function? Increasing, because e is a number bigger than what? 1. Good. So I just need to plot a few points and I'm done. Give me the number for x.
2.
Okay, let's do 1 though, and we'll do 2. So I get e to the first. E to the first, which we know is what to the thousandths place?
2.718.
2.718. Now let's try, let me plot that point. So remember we're approximating now. So 2.718 is about here. It's close to 3, right? So just because of those 2 points, you know that on this side it gets closer and closer to the horizontal asymptote. I need one more point. So let's do 2. If x is 2, I get e squared. Now don't say e squared is twice 2.718. That's not true.
7.389.
7.389. So when x is 2, I get e squared, which is approximately equal to 7.389. 7.389, which is closer to 7 than to 8. But right here, and then just connect them and you're done. This is it. That's all it is. Okay? So just knowing how to use your E function in calculator. All right, now let's do one more with E. Let's do this. Oh, what's the domain?
Negative infinity to infinity.
Yep. What's the range?
0 to infinity.
All right, what else do I need? We did the y-intercept. The y-intercept is 1 or as an ordered pair 0, 1. Increasing, decreasing. Increasing or decreasing? It's increasing. Okay. All right, let's do one more, and this is the one we're going to do. Listen carefully. Graph h of x equal negative e to the x plus 4.
Okay, so 4 is not part of the exponent.
No, the 4 is on the outside. So graph h of x, which equals negative e to the x plus 4. What's the horizontal asymptote?
4.
Nope.
Y equals 4.
Y equal 4. So you draw the horizontal asymptote. Is the graph above or below? Below. Why is the graph below the horizontal? Because that reflection. This reflection. So it's going to be below. But what's the domain, though?
Negative infinity to infinity.
Because it's what kind of function? Those are what kind of function we're dealing with here? Exponential. All exponential functions, I can use any number for x. So hence, negative infinity to infinity. Since I can use any number for x, then I can let x be 0, which happens to be the y-intercept. So let's find the y-intercept. If x is 0, I get negative e to the 0 plus 4. Now be careful. What's e to the 0?
Negative 1.
No, what's e to the 0? 1.
1.
But this says I take the opposite of 1, so what's the opposite of 1? Negative 1. Negative 1 plus 4 is 3. So I plot the point 0, 3, and notice, guys, it is below the horizontal asymptote. All right, let's do a point to the right, see what happens. If x is 1, now you need your calculator for this one. If x is 1, I get negative e to the first plus 4. Negative e to the first plus 4. So on your calculator, do this. Your negative button's right here. And then I got to press second e to the x. But what's the exponent for this? 1. Close it. You got to close it. And then add what? 4. You get about 1.282. So 1.282 is 1.282 is about here. Right here. So that means that on this side, the graph goes towards which part?
The horizontal.
Horizontal asymptote. And on this side, it falls rapidly. Now, I should apply one more point. Let's do one more point. Let's say x is 2. If x is 2, I get negative e squared plus 4. So use your calculator. Tell me what that is.
Negative.
Make sure you know how to use your calculator, because on your test 3 and the final, possibly the final, you're probably going to have to graph an e function.
Negative 3.389.
I'm just writing what he's telling me. Make sure y'all checking.
I got the same.
So 2, negative 3.389 is here. So I should have applied the point before graphing it. Now, is this an increasing, decreasing function?
Decreasing.
Decreasing. Now, guys, you knew it was decreasing because listen to what I'm about to say. You knew it was decreasing because E is a number bigger than 1, right? So that's increasing. But the reflection makes it do what? Decrease. All right, decreasing function. All right? Okay. So you've had enough problems to where you can graph an exponential. They're very not too difficult to do. All right, now here's a formula that you're going to use. So write this formula down. So we're going to start talking about